Hey, what's up everyone? Ethanator here, and I just got done building this Blade Fusion 550 quick build kit, and like always, it went together effortlessly. It's probably one of the easiest and fastest building helicopters out there on the market right now, which is perfect for any RC helicopter pilot who might want to try their hand at building. And if you opt to use the super combo of Spektrum electronics, that is an option with the quick build kit, it makes the setup process a whole lot faster as well, just because everything from the ESC to the flybarless unit tuning and setup is all done through your Spektrum transmitter. And that's what this video is going to be dedicated to. I haven't even plugged in the model yet, so this is going to be a ground up, basically setup to get your helicopter ready to maiden. So basically we're going to start off with setting up the model in the transmitter and then binding it to the FC6250. So without further ado, let's get on into it. All right, so first things first, we are going to create a new model in the transmitter for the Blade Fusion 550. I have the Spektrum NX20 right here. It's got the nice big screen right here, so you should be able to see what I'm doing pretty well. So first, we're just going to go into Add New Model. As you can see, we want the model type to be a helicopter. We're going to create it. Now, the good thing is a lot of the stuff as far as the servo setup, dual rates, and expo are already set. You don't want to touch those because a lot of the setup and tuning will be done through the flybarless unit and forward programming. Now, the first thing that we want to do is we want to go into our flight mode setup, and typically it is automatically assigned to switch B, which is over here. You can always change that if you want to, but I'm going to make sure that my hold switch is active. So I'm going to be using the back right switch, which is switch H. So all you have to do is flip the switch for it to recognize it. And as you can see, we have hold mode now, we have normal, flight mode 1, and flight mode 2. One thing that I also like to do with pretty much any helicopter that I set up in my radio, I go to the warnings menu and I actually change the hold warning, because typically it will warn you by default if the throttle hold is activated. I want it to warn me if throttle hold is not activated, just for safety purposes. So all you have to do is come down here. Default would be that. Basically you want the black box right here to be active on 0. So now let's just say I'm not in a hold mode and I go back to the main menu. It's going to warn me hold mode is activated, so now that there's no chance of the helicopter spooling up. Back at the main menu, the next thing that we want to do is go down to our gyro setup, because the FC6250HX wants to see a 75% value to start off with. Now this can change in the future depending on how your tail behaves. If the PIDs in the flybarless unit cannot seem to get a odd behavior out of the tail, then the next resort is to try with the gyro right here. But to start out, you want 75%. So what we're going to do is we're just going to get it activated by flipping switch B. So our actual switch that we want is going to be flight mode. So basically where you see on, past on is going to be flight mode, and the channel you want is gear. So we are going to set the percentage to 75% for all of these values. And just like that, we have our gyro set up. The next thing to do now is rename our helicopter if we want to, and then bind up the helicopter to the transmitter. One quick other thing to do if you have the Super Combo kit is to go into System Setup, and we're going to go down to the frame rate. And right here, we can change the servo mode to hybrid 11/22 milliseconds. With the model set up in the transmitter, the next step is going to be binding it to the Fusion 550. Now, as a safety precaution, I do have the main blades removed, which is highly recommended when setting up pretty much any RC helicopter. Now, a couple things to note with the Avian Smart ESC, we actually have the signal wire, which is basically the gray lead coming off of it, along with the orange and black lead for positive and negative. That's going to be plugged into port 2, and then on port 6 is the extra BEC wire, which is just the orange and black servo wire coming off of the ESC. Now, with those plugged into the corresponding spots, we are going to bind up this helicopter. Now, it is a two-step process, so the first step is binding up the SRXL2 receiver to the transmitter, followed by inserting the bind plug and binding up the DSMX remote satellite receiver, which is mounted on the other side of the helicopter, to the transmitter as well. So to kick things off, we're going to plug in the model right here. Going to hold down this button on the SRXL2 receiver, and you will see that it is flashing. So now all we have to do is go down to bind on the function list. We'll bind it. And just like that, the SRXL2 is bound to the transmitter. One thing to note as well, you aren't going to have any movement from any of the servos. This is because in the FC6250 we have not told it what type of servos we have, so you are not going to get any movement. But if you see a solid orange light, you know that the bind was successful. With the model unplugged, we can now bind up the DSMX remote satellite receiver. So what we are going to do is start off by unplugging the SRXL2 receiver, which is in the bind/program/receiver 2 port. So just unplugging this right here, we can replace it with the bind plug. With the bind plug plugged into the bind port, the next step that we can do is bind up the SRXL2 to the transmitter. So powering the helicopter on once again. You can see that the bind plug has put the remote receiver into bind mode right here. And it's basically just going to be the same exact process, going down to bind. You can see that we have bound to the remote receiver, the light is solid, and the helicopter is completely bound to the transmitter. Next, we can unplug the bind plug again and plug back in the SRXL2. Whenever we plug into the helicopter, we should have a solid light on both the SRXL2 and DSMX remote satellite receiver. As you can see, we have a light right there, and a light on the SRXL2. So that means that the helicopter is completely bound to the transmitter. Okay, so the next step that I'm going to do is set up the Avian ESC. Now, if you have a Spektrum transmitter like this NX20, it makes setup effortless because you can do it all through the transmitter. So all you have to do is plug in the helicopter, scroll all the way over to Avian Prog. Now, what we are going to do is in step 1, we're going to hold up elevator and left aileron. For step 2, you can move it to the right aileron just like so. And as you can see, we can change the settings right here. So for this helicopter, we want the flight mode to be HeliStore Gov. Going down, we can skip the brake type, we can skip the brake force. The cutoff type, we can do soft cutoff right here. So basically the head speed will gradually decrease if the battery becomes low. So basically for LiPo cells, you can just do auto calculate, cutoff voltage. That can remain at 3.4. BEC voltage, for this helicopter, you want to make sure that it says 6 volts. Startup time, we can just keep it at soft. Timing, keep it at 15. Motor rotate, we'll keep it at clockwise. Active freewheel can remain disabled. Governor gain can stay at level 1. So the AR time, so this is basically your throttle hold bailout. So essentially, if you activate throttle hold, and let's say you're doing an auto rotation, and you decide that you want to spool back up again, if you flip out of throttle hold within 45 seconds, then it will ramp up super fast like a auto bailout should do. Now, this is the restart acceleration for that, but going back to the AR time, I'm just going to completely disable this. So if you go left, you can see that it says 0 seconds, which essentially means that it is disabled. So restart acceleration, we're just going to keep it 1.5 seconds because it doesn't really matter right now what we have it set to since the AR time is at 0 seconds. Thrust reverse, we can just leave that alone as well. And all we have to do is exit with save. Now it's time to set up the flybarless unit through the transmitter. So this is done by accessing forward programming. So with the helicopter plugged in and connected to the transmitter, we can access forward programming right down here on the function list. Going into forward programming, we're going to go into setup, swash plate, output setup, and right here is where we're going to select the frame rate to basically give controllability to the servos from our transmitter. So our frame rate for the Spektrum H6350 cyclic servos is going to be 333 Hertz. Now, as you can see, we don't have control on the cyclic servos just yet. this is where we are going to navigate to the swash plate setup. And for the type on this helicopter, we want 3 servos, 120 degrees. Now, as you can see that there's an A, B, and C, this corresponds to where you are going to plug in your cyclic servos into the FC6250HX flybarless unit. So just keep in mind, you can look in the manual, or I can even pop up a little description right here showing which ports go into where on the flybarless unit depending on which servo you have on hand. But for the 3 servos, 120 degrees, you're going to have A as your right aileron, B is basically your elevator, and C as your left aileron. So just keep that in mind right there. So make sure that it is on 3 servos, 120 degrees, like so. As you can see now, we have collective pitch right here. This is now where we are going to go into the direction right here. And as you can see, the output on all of the channels are on normal, assuming that you have a freshly set up flybarless unit and also that the servos are plugged into the correct location. Now, with the super combo, you can actually leave all these output channels to normal. As you can see, basically the main goal is to get collective pitch on all 3 servos in the positive direction, like so. Now let's say that you plug in all the servos in the correct location and you go positive pitch, and let's say one of the servos is reversed, so like we'll just say the channel 1, so the right aileron is reversed. As you can see, the swash plate is not giving the indication of going positive pitch, so you can reverse the servo as necessary to get all of the servos working together to achieve positive collective pitch whenever you move the stick in the positive direction. Moving back out of direction, we are back at the output setup menu, and the next thing that we are going to do is subtrim. So clicking in the subtrim, you can see that all of the servos go into center, and this is basically where you can subtrim your servos as necessary. Now, the first thing that you want to make sure is that mechanically your arms are as close to 90 degrees perpendicular to the servo as possible, like you see here. And also you want to make sure that your linkage arms right here for the swash plate are appropriate to the length that it gives you in the helicopter kit. Now on the Blade Fusion 550, they should be very, very close to the given amount of millimeters that you want in the length of these arms. So just make sure before you subtrim anything in the flybarless unit that this is mechanically set up as close to 90 degrees as possible. But again, if everything cannot be perfectly 90 mechanically, this is where you can subtrim the servos to get the arms perfectly 90. With the cyclic servos set and the blades off of the helicopter, right now is a good time to test the motor direction. So basically you can just power up the helicopter just a little bit. You can see that the main head spins the correct way. If the motor was reversed, it would just be spinning the one way and the main head would not be spinning. If that was the case, all you'd have to do is swap any 2 motor wires into the ESC and it will change the direction of the motor. Back in the subtrim menu in forward programming, this is a perfect opportunity to get 0 degrees pitch by adjusting the rotor linkages back here. Keep in mind they are turnbuckles on the Blade Fusion 550, so you can be really precise in the given pitch. This is also a great time to do so because in the subtrim menu, the servos are basically neutral, allowing you to set up neutral pitch and also your blade tracking. With 0 degrees on both blades in the subtrim menu, you can go back and then hit back once again. And now you can go into the AFR menu. This will basically limit your degrees of travel. So first of all, we want to acquire our roll and pitch. So for our roll, whenever we apply aileron, we want to see 12.5 degrees on the cyclic. Now, as you can see right here, we have 11.9 going right, and going left we have 11.6. So it's roughly close. As long as you're within a degree on both sides, you are good to go. So I am now going to adjust the roll and increase it until I see 12.5 right here on the aileron. And as you can see, it's 12.5, 12.6, either one is good. Up next, we can adjust the pitch in the AFR, and like the roll, you want 12.5 degrees. So as you can see, we have already 2.1. This is just because of the way the helicopter sits on the skids. So basically, we want to see 14.5, which is basically 12.5 plus the 2 degrees that is already in there. So basically, we are going to increase until we see 14.5. which is right there. So 14.5, going back, it will probably be around 11, which is really 13.1. So that's totally fine too. Like I said, as long as it's within a degree, you are good to go. And last but not least, we can set up our collective. So going positive pitch, you can see that there's 12.9, basically 13 degrees, which is usually around what I want. I might bump it up one more. So as you can see, 13.2. Now going to the bottom, you can see that it is at 12 degrees. Now this is where the differential comes in. So as you can see, you can go one way or the other. So since we are in negative, we can go negative on the differential, and you can see that we can acquire 13.1 degrees, and up top, we have 13.2. So in summary, on the AFR, adjusting collective will affect both positive and negative pitch endpoints, whereas adjusting the differential will only affect one endpoint without affecting the other. The AFR menu is also a good place to make sure that the cyclic direction is the correct way. So for example, whenever you go right, the swash plate should tilt right, left, the swash plate should tilt left, forward, the swash plate will move forward, and back, the swash plate will move back. If this is reversed for whatever reason, you can actually see that the value is 82. If we went on the roll and went to negative 82, like so, we'll just say like in the negatives, you can see that it basically reverses the direction. So you don't want to reverse the servos at all through the transmitter or anything like that. All you have to do is change the value from a positive to a negative. So I'm going to go back the other way, as you can see, just like that. And I'm going to go back to 82, since that was the correct value in order to get the desired travel. Back at the setup menu, we can now set up the tail rotor. So going into tail rotor, output setup, we are going to change the frame rate to 560 Hertz since we are running the Spektrum H6360 tail servo. Now, as you can see right here, the slider moves left along with the stick, which actually isn't correct. So what we are going to do is go to direction and reverse the direction. Now you can see that the tail is moving the correct way, like so. Going back, we can go into the subtrim menu, and this is whenever the tail rotor servo will center. And this is basically whenever, it's just like the cyclic servo, you want the arm as close to 90 degrees as possible to the servo whenever you first install it, and then followed by that, we can fine tune it with the subtrim right here. And in return, we want this tail bell crank right here. Basically this piece right here, we want it parallel with this side plate. So I already know that I got it pretty close, so I'm going to subtrim until I see this right here as close to parallel to this plate as possible. So going back, we can now go into the travel, and this is where we are going to check for any binding. I don't hear any, so honestly we don't have to decrease it. I wouldn't go past 100 for an optimal tail setup, so I'm just going to leave it at 100 like so. And just like that, the tail rotor is set up. And lastly, we are going to go into gyro settings, so then the gyro can learn the orientation, and then afterwards it's also going to calibrate itself. So one thing that I like to do in order to make sure that the flybarless unit is level is get a bubble level like this and make sure it is in the middle. Typically with the Fusion 550, you will have to put some weight on the tail to get the tail fin to touch on the table or whatever surface you are working on, so then the bubble level is as level as possible. So once you have the flybarless unit level, we are going to go into orientation. And on the orientation settings, as you can see right here, you can change between all of the different orientations depending on what your orientation is on your flybarless unit mounted to your helicopter. So the way that we have this one mounted, we want orientation 1. Whenever we back out of that, you will see that there is a calibrate sensor option. We are going to select begin. As you can see, the sensor is calibrating. And just like that, the calibration is complete. So we can just select complete. And now you can always go back and calibrate the sensor. I always recommend this in the case of a crash, but since we just calibrated it, we do not have to worry about that. So going back into forward programming and exiting the menu, all the setup is done through the forward programming. At this point, you can now test the direction of the gyro. If the orientation was set correctly, the gyro will correct the swash plate and the tail in the correct direction. And the last thing that you really have to set in the transmitter before you made in the helicopter is your throttle curves. Now, this is totally depending on the pilot. Some people like to run a linear curve like so. I typically like to run a flat curve of 55% on normal, maybe like 65 to 70% on stunt 1, and stunt 2 for around 2,500 RPMs, I like to run roughly around 83%. But yeah, it's essentially it. And then obviously on hold, you just want a flat 0. So all you really have to do is go in here and adjust the throttle curves as necessary, whatever you want to have as far as head speed on your helicopter. And that's pretty much it. Thank you all so much for following along. Hopefully you all saw just how easy it is to set up the Avian ESC and also set up the FC6250HX flybarless unit all through your Spektrum transmitter. So good luck on the maiden on your Blade Fusion 550 quick build kit or any other helicopter that you might have this combo in, and we'll see you all in the next one.